If you've ever looked up at the night sky, wondering about the farthest reaches of the universe, you're not alone. For centuries, humans have been fascinated by the vast expanse beyond our planet, trying to comprehend the scale of it all. But how do you explore something so far out, something you'll never be able to physically reach or see with your own eyes? The answer lies in the incredible power of telescopes launched into the void of space. NASA, with its cutting-edge technology, has done just that with the James Webb Space Telescope, JWST, one of the most advanced instruments ever built. This groundbreaking observatory is designed to peer into the deepest, most distant corners of the cosmos, to the very edge of the universe. But what happens when we look out at the universe's edge? What will we see when we gaze upon the farthest reaches of space? The discoveries that await could be mind-boggling, even terrifying. In this episode, we'll explore the astonishing revelations brought to light by the James Webb Space Telescope and delve into what these findings mean for our understanding of the universe and, by extension, ourselves. Since time immemorial, humans have been driven by a fundamental curiosity about the world around them, especially the world beneath their feet. As technology advanced, this curiosity expanded, and we began to turn our gaze upward toward the heavens. The invention of the telescope, which dates back to the late 1500s, marked a revolutionary moment in the history of astronomy. However, it wasn't until 1608, when the first practical telescopes were created in the Netherlands, that humans gained a true tool for observing the distant universe. This marked the beginning of our quest to understand the cosmos on a deeper level. The true potential of telescopes was fully realized through the work of Galileo Galilei, one of the most famous astronomers in history. Galileo, inspired by a Danish invention known as perspective glass, built his own telescopes and used them to explore the night sky. His findings changed the course of science forever. For the first time, humans could see celestial bodies in extraordinary detail, far beyond what the naked eye could perceive. In the beginning, Galileo's telescopes could magnify objects by a factor of just 3, but later models improved dramatically, eventually offering magnification powers of up to 30 times. What Galileo realized was something revolutionary: that a tool designed to magnify distant objects could completely alter our understanding of the universe. His telescopes helped us see that the Earth was not the center of the universe, but rather one planet among many orbiting the Sun. This realization shattered centuries-old misconceptions and ushered in a new era of scientific discovery. Fast forward to today, and the relationship between telescopes and space exploration is inseparable. Space is so vast that without these instruments, much of the cosmos would remain a mystery. Take, for example, Proxima Centauri, the nearest star to Earth. It lies about 4.2 light-years away, which translates to a staggering 25 trillion kilometers. The distances between stars and galaxies are so immense that it would take us years or even centuries to reach some of them with current spacecraft technology. Even Elon Musk's ambitious plans for colonizing Mars would require months of travel. In such an expansive universe, telescopes are essential tools for exploring the unknown. They allow us to look far into the cosmos, examining distant stars, planets, galaxies, and other celestial objects in greater detail than ever before. Instruments like the Hubble Space Telescope, which has been orbiting Earth for decades, have provided us with awe-inspiring images of the universe. But now, with the James Webb Space Telescope, we have an even more powerful tool at our disposal. JWST is equipped with state-of-the-art technology that can peer into parts of the universe never before seen. Although Galileo might not have envisioned a world where massive, international telescope factories produce instruments costing billions of dollars, the investment in telescopes like the JWST is undoubtedly worth it. The James Webb Space Telescope promises to be the most important astronomical observatory of the coming decades. Thousands of astronomers from around the world will use it to explore the universe's origins, from the first flash of light following the Big Bang to the formation of stars, galaxies, and planetary systems that could one day support life. The JWST is equipped with an array of powerful instruments, including cameras and spectrometers, all designed to capture faint signals from the farthest reaches of space. One of its most remarkable features is the near-infrared spectrograph, NIR spec, which can observe up to 100 objects at once, making it an incredibly efficient tool for studying multiple celestial bodies simultaneously. Another breakthrough innovation is its cryocooler, which lowers the temperature of its mid-infrared detectors to just 7 Kelvin, colder than outer space itself, allowing it to detect faint infrared radiation from some of the oldest galaxies in the universe. But the question remains: how do we even begin to comprehend what lies beyond the observable universe? Based on our current understanding of physics, we know that the universe is spatially flat, meaning it has no discernible curvature, and that it may stretch far beyond what we can see. Current estimates, based on data from the Sloan Digital Sky Survey and the Planck satellite, suggest that the observable universe is at least 250 times smaller than the unobservable portion. This means that the universe may be far larger than we can even imagine, possibly spanning a mind-boggling 23 trillion light-years in diameter. Even though we can only observe a small fraction of the universe, we've still made remarkable progress in understanding the boundaries of space. For example, the cosmic event horizon lies about 16 billion light-years from Earth. This marks the farthest distance from which light can currently reach us. Beyond this point, the expansion of space itself outpaces the speed of light, which means that anything beyond this horizon will forever remain out of view. Yet, thanks to the James Webb Space Telescope, we are now able to peer deeper into space than ever before. The GNZ11 galaxy, located approximately 32 billion light-years away, is the farthest galaxy we've ever observed. This distance takes into account the accelerated expansion of the universe since the light we see from this galaxy was emitted. We can also observe the surface of last scattering, located about 46 billion light-years away, which represents the earliest light emitted after the Big Bang. It's essentially the fog of cosmic microwave background radiation, the first light to ever travel across the universe, marking the birth of the cosmos. But here's the kicker. While these distances are mind-boggling, they don't mark the true end of the universe. In fact, everything beyond our observable reach is still part of the cosmos. It's simply beyond the limit of our observational capabilities. The universe, as we understand it, extends far beyond the event horizon that defines our current field of vision. One of the most fascinating questions we must confront is whether the universe is infinite. Einstein's theory of relativity suggests that the universe could be infinitely flat, extending endlessly in all directions. This theory opens up the possibility that, while our observable universe has limits, the cosmos itself might have none. The universe's origins are just as mysterious. Before the Big Bang, the universe underwent a period of rapid expansion known as cosmic inflation. During this time, space itself expanded exponentially, stretching to the size of our observable universe in a fraction of a second. This rapid expansion has left us with many questions about the true volume of the universe and whether it has an upper limit. While we know that inflation has stopped locally, questions remain about how much of the universe was affected by this early period of expansion. Additionally, new theories suggest that our universe might not be the only one. The concept of parallel universes, or bubble universes, proposes that there could be many other worlds, each with its own set of physical laws and cosmic structures. If this theory holds, the notion of life on distant planets becomes all the more intriguing, with countless other worlds possibly harboring the conditions necessary for life. As we peer into the future and explore the universe's horizon, we realize just how much we still have to learn. The universe may be far vaster and more complicated than we could ever imagine. And while our ability to observe it is limited, the discoveries we've already made are just the beginning. With the James Webb Space Telescope at our side, who knows what incredible revelations await us in the future? What do you think lies beyond the known universe? Share your thoughts in the comments. If you enjoyed this exploration into the mysteries of space, don't forget to hit like and subscribe to our channel for more mind-blowing space discoveries. Click the video on your screen to dive deeper into another incredible chapter of our exploration.